Assuming that you used Android before, what's your opinion on Android versus iOS apps in terms of UI? All right, iPhone feels a little smoother, right? So now we all know that there are fundamental differences between user interface design on Android and iOS. But even then, it seems to me that somehow Android apps often get bad rap about their UI and UI performance compared to iOS apps. But with the right tools and mindset, we can actually make Android UI feel just as good as their iOS counterparts, or even better. So today I'll be talking about how to build beautiful and performant user interfaces on Android. So how many people here use Instagram? Nice. Okay, how many of you have used the Search and Explore tab? It's the second tab where it has a magnifying glass. All right, not bad, not bad. Okay, so how many of you have tapped on one of these cool images at the top, like that horse photo, and seen something like that? No one? All right, everyone from Instagram. All right, so I worked on this feature. This is a fairly new feature in our app, and we call it the Immersive Viewer. It's been out for several months now, and I was hoping that more people recognize it, but clearly we need more people on board. So now the reasons why I'm pointing out this specific feature is because, one, like I built it, and two, I'm going to be using it as an example to demo many of the UI tips and tricks I'll be presenting today. So I thought I should introduce it for those of you who've never used it before, so you have an idea of what I'm talking about. But that actually seems like everyone here. So, but most importantly, I want to briefly share the development process we went through at Instagram to build this new feature, because I think it's a great example of how a good user interface isn't built on the first try, but rather over many iterations and after incorporating feedback from real users. So when we were building out this new feature, we had these goals in mind. We wanted to provide an immersive user experience where you come to watch a ton of funny, creative, and engaging videos from special events like Halloween, New Year's Eve, and even Pi Day, for those of us that care. And when you're in the experience, you'll be able to just sit back and watch. The viewer literally scrolls for you at the end of each video, so you don't have to. But of course, you can scroll it yourself if you want, at the pace you want. Now, what's exactly different about Immersive Viewer from our normal feed? So on the left here, we can see the traditional Instagram feed that everyone's used to. And on the right, you see the viewer. First of all, the viewer paginates and centers the playing video in the middle for you so that you don't have to scroll as much. In the feed, you have to manually drag and make sure the video is in the viewport. But in the viewer, with a simple fling or tap, you can just go to the previous or the next video. This also means that only the center video is playing in the viewer at any given time. Now, we removed all the other existing UI components as well that are seen on the main feed, except the user header and the video itself. So for example, the video icons, they're gone. We also removed the feedback interface, which includes the action buttons, the number of likes, and the list of comments. Now, we removed the bottom tabs as well and hid the status bar so that the viewer can take up more of the screen space, providing a more immersive experience. But we did keep the navigation bar because users are used to having the nav buttons always available on screen, and it would be annoying to take them away. And lastly, we give the viewer a dark theme, and only the center video, the one that's playing, is highlighted so that the user can easily focus on it. Now, while this looks rather simple to have built, we actually didn't start with that exact design in mind. We started with a different design, went through numerous iterations and some painful churns, and finalized on that design. And by churns, I mean we had to take out some parts of the feature that weren't working too well given our user research. So this is how it all started with this first prototype of the viewer. I basically extended list view and added custom touch event handling by overriding dispatch touch event. This allowed me to reroute the touch events to our gesture listener, which would determine whether we should consume these events and do a custom action or just let the list view handle them. For example, for a fling action, our custom list view would consume it and do the fling animation so that the viewer paginates correctly, but other scroll actions like dragging would be handled by the list view. Now, we all wish that app development was all fun and games, but sometimes we just have to face reality. where we have to let go of features that feel out of place or don't provide much value to the overall product. So the first churn was with this scrubber feature. It was basically a row of thumbnails at the bottom of the viewer that you could tap or scroll to navigate horizontally. And the list view was updated to show the correct video based on the position of the scrubber. You could still scroll the list view vertically as well, and in that case, the scrubber would animate its position correctly. Now, it also helped show how many videos there are in the viewer and how far you are from the end. Now, when we demoed the scrubber during our UX research sessions, people felt neutral about it. Mainly, some people were confused by being able to scroll the viewer both vertically and horizontally, and most of them just ended up scrolling the list view instead of the scrubber anyways. So we ended up removing the scrubber, and I was sad. Now after that, we added some more features, one of which was a progress indicator for the playing video. We added a sliver of white line just above the video to tell the user how much of the video they've watched in real time. Now this didn't turn out to be a great idea either. Now we call it dogfooding when our employees are testing our own products, and people are frequently reporting that the progress bar was really distracting because it would move while the video was playing and take away attention from the video itself. So this was bad. So soon enough, it was gone. And I was sad again. But going through these churns, they really show the importance of testing on real users and focusing on what they like and don't like. And all the feedback received really helped us make the Immersive Viewer better by removing features that were hindering the user experience. Now after that, there was hope. We added some new designs. For example, the new attribution which displays information about the user who posted the video. So originally we had the attribution at the bottom of the video, and we had to stay there the whole time while the video was playing. Then we realized it was actually obstructing the video, so we made it appear only if you tap on the video. But this also became a problem because not many people would realize to tap on it to see it. And they would just go without knowing who the poster was. Now to make this information easily accessible, we changed the design to look like this. So not only did this new attribution give more context about the poster, but also people were reporting that it made the viewer feel more like Instagram because the header here resembles the header from feed, and it's more recognizable, which was great. Now, then we also blurred the surrounding videos to make the center video easier to focus on. And as you can see, without the blurring on the left, the other videos are too crisp and distracts the user. Now for a nice finishing touch, we added some shadows to the top and bottom of the center video to make it more prominent and have this cool floating effect. Again, this helped accentuate the playing video. And this is actually the final design of the Immersive Viewer that we have in production today. So now that we all know how the Immersive Viewer, we all know what the Immersive Viewer is and how it evolved, we can go to the fun stuff and talk about some of the UI tips and tricks I used to build the viewer and how you can reuse some of these to build great looking UI yourself. These UI tips and tricks will be focused on principles like providing pleasant user experiences with animations, caring about performance, and doing the little things that go a long way in product quality. First, delighting your users with animations. So how I view animations is that they should be super slick and smooth in the way that they feel natural and the user doesn't even notice them. But if they were to suddenly go away, the experience will be noticeably worse. So let's start with spring animations. So to use spring animations, you just need to use a library called Rebound. Some of you may have heard the talk by Will Bailey in the previous talk. And it was built by one of our engineers, Will. And now when you use spring animations in your application, they make the experience feel more organic and alive by applying real-world physics. Instead of, for example, let's say linear or quadratic interpolations, which you'd get by using the Android's animation or animator classes. And without going into too much details, this means that real-world properties, like the velocity at which the user flings their finger on screen, can be incorporated into a spring animation to reflect the motion, and also the eventual decay in movement caused by friction. Now let's take a look at this short code snippet of how to do a simple spring animation using Rebound. So with this code, The goal is to translate an image vertically by some distance x with a spring animation. So first you create a spring system, and then you create a spring in that system, and then you create a spring config with the amount of tension and the friction you want to see in the animation, and set it as the config of the new spring. Then you attach a listener to the spring to be notified of changes to the current spring value, which would be like the animation callbacks that you will use to change the image's translation Y property. Now to actually start the animation, you put the spring in motion by setting an end value. The default start value is 0, so when you set an end value of 1, it'll go from 0 to 1. And so with this animation, the image will go from 0 translation to full translation by some distance x using the motion of this spring. Now, I didn't go into any details on what each class here does, as it's kind of outside the scope of this talk. But you can check them out at this link, or ask Will since he's here with us today. Now, let's take a look at how spring animations are used in the Immersive Viewer. So all of its animations are actually synced together using one spring. For example, the paging, the alpha animations, and also when we used to have the scrubber. Now, this was to make sure that the animations, they all start at the same time and also finish at the same time. Otherwise, let's say that the paging animation finishes before the alpha animations do, then the views would continue to change in opacity even after they have settled, and this incorrect synchronization would be noticed by the user, hence providing a bad experience. So to prevent this, everything animates together when the viewer is auto-advancing or the user is scrolling. Now, here's a demo. Yeah. Now, if you recall what I said earlier about how spring animations incorporate real-world properties like velocity of a fling action, this is a great example. Here, you can see that when you fling the viewer, the paginating animation respects the velocity of the fling. If you fling lightly, the viewer paginates with the respective low velocity. If you fling hard, the viewer paginates with the respective high velocity. This is exactly why we chose springs to drive these animations. They apply real-world physics to provide natural experience in our UI. Now, to do all the animations, the viewer is structured in code like this. We have this scroller object, which encapsulates the spring operations and also tracks information like the current list view position of the center video. Then we have the list view, the scrubber, and the other listeners like the fragment listen to the notifications from the scroller. The fragment needs to listen as well because it handles some of our video playing logic. Now, let's take a look at a fling action as an example. Now, the list view consumes the fling action and it triggers a vertical scroll event through the scroller, which sets the underlying spring in motion with the appropriate velocity and the target offset. Then when the spring value updates, the scroller gets notified and it invokes the appropriate callback on every listener who's interested. Now, when you need something to come into screen or go out of screen and you just change the visibility of the object, it feels quite jarring because things appear and disappear out of nowhere. Alpha animations can really make this experience richer. We use a ton of alpha animations in Immersive Viewer. So let's take a look at an example of how something in the viewer looks with and without the alpha animation. So on the left here, we just changed the visibility of the header when the video changes without any alpha animation. On the right, we actually animate the alpha of the header whenever you're scrolling or paginating to another video. Now, as you can see, the experience is much more natural and smoother on the right as the current header fades out and the next header fades in. And on the left, it feels quite choppy with the headers popping in and out. And this becomes clearer when you're going backwards in the viewer. Now, scale animations can also complement the UI if used in the right way. They can especially be used to create cool visual effects, like an animation to indicate to users that they're entering a new view. Let's take a look at an example for Immersive Viewer. So on the left here, we don't have any animation when going into the viewer. The new view just pops in and out, and it feels just okay. Now on the right, we have this opening animation where the black background starts at a zero height in the middle, and scales up to fill the entire screen. The motivation behind this was to make it look like you're turning on an old television. Now you can see how the animation makes the entrance less abrupt and gives the user an expectation that something new is opening and closing, which is exactly what we wanted for the viewer. Now you can even combine the different animations we just talked about to create even more enhanced effects in our UI. Now as you see on the left, when you tap on the video pauses and the menu becomes visible. And this again feels just okay with the visibility being changed. Now let's see what happens if we combine some animations to make this smoother. So when coming into view, the buttons start scaled up and then they scale down to their original size, while at the same time fading in and using a spring to have a subtle bounce effect. Then when the buttons are going out of view, these animations are reversed. Now that's a lot more code, but it feels less jarring and is a nicer experience than what we had before on the left. Now building UI with cool animations and beautiful designs is important, but none of it is worth it if the performance is bad. We need to make sure to not degrade the performance while improving the design and feel of the UI. We can do that by making the correct optimizations. Now there are many different kinds of performance improvements that you can make, but I'm going to focus on some of the ones that I made to the Immersive Viewer that really helped with keeping it smooth and performant. Now one optimization I made to the viewer was to reduce the number of views to a minimum. Now this is important in any application. The more views you have on screen, the more work your device has to do to render them. Not only that, we use up more memory as well as more time to instantiate all these views. So it's great if you can avoid all these extra resources from being used. So in Immersive Viewer, we used to have 4 views. So one view for the blur image, and also another view for the dark color overlay when the video is not in the center, and also a view for each of the top and the bottom shadows. Then we were able to condense this down into just one custom view where we just extend image view for the blur image, and we override the onDraw function where we draw the color for the dark overlay and then draw a drawable one for each shadow. And then on animation callbacks, we would just set custom alphas on the view, on this custom view, and invalidate it so that its onDraw method will run again and reflect the correct state of the animation. I also had to optimize the alpha animations in the viewer because we animate the alpha property of several elements at the same time whenever the user is scrolling. Basically, if you're using an alpha animation in your app, you have to make sure to use the set alpha methods correctly. There are 2 ways you can change the alpha property. One way is to call the set alpha method in view.java, which takes in a float between 0 and 1, 0 being transparent and 1 being fully opaque. Now this method is actually a 2-step process where the first step is to allocate an off-screen buffer called a hardware layer and draws the view onto it. Then in the second step, the GPU copies the pixels from the hardware layer to the screen, applying any alpha value that we set. Now the advantage of this 2-step process is that the alpha blending will be correct on overlapping content on screen. But the huge downside is that the first step actually adds a lot of overhead because we have to create this buffer in GPU memory. Now there are ways you can optimize a set alpha method for a view, but each approach has some catches. So one way is to set the layer type of the view you're animating as a hardware layer type. This caches the hardware layer and reuses it so that we only have to do the allocation step once. And we still get the benefits of having the GPU draw directly onto screen, which is very fast. However, not only does this still take up GPU memory, so you have to remember to release the layer whenever you're done using it, but also this approach loses a lot of its perf gains if you invalidate the view too many times during the animation, because the hardware layer gets reallocated every time you call invalidate. Now this approach keeps the alpha blending correct and makes the alpha animation very performant if used correctly. But unfortunately, it doesn't fit every use case. For example, Immersive Viewer is an example where we don't want to use this. Because the viewer is built on list view, and the list view recycles its children views and can rebind them at any time during a paging animation, we can't just cache and reuse hardware layers to get the performance benefit because they will keep getting invalidated. Now the other way is to make the set alpha. Now the other way to make set alpha method faster is to create a custom view, override a method called has overlapping rendering and return false. Now this bypasses the hardware layer step, and the view is drawn directly to screen when you change the alpha. Now there are some downsides to this approach. The first one is that the alpha blending will be incorrect on overlapping content, but this really depends on your application, whether you need it to be 100% correct, and in many cases you probably don't need it to be. But the biggest downside of this approach is that you have to define a bunch of custom views if you're doing a rather complicated animation. So let's say you're using a view group and want to assign different alphas to each child, but you won't be able to just override this method in the view group. You would basically have to define a custom view for each child and override this method, which isn't exactly ideal. Now going back to the viewer, neither of these approaches were ideal to optimize our alpha animations. So we didn't end up using the setAlpha method in view.java at all. So what's the alternative? So the alternative is to use the setAlpha method of a drawable. This basically changes the alpha property of the drawable instance as opposed to the view. It doesn't use any hardware layer, so the drawable is drawn directly onto screen and is a very fast operations. Now compared to the has overlapping rendering approach, this is nicer because we can just change the alpha value of the drawable underlying our view instead of having to define a custom view. Now the only catch is that the alpha blending will be incorrect on overlapping content as well, but it doesn't matter in the case of the viewer because one, we have very few overlapping content, and two, we don't need 100% correct alpha blending. Now here's an example to show the difference in performance between the two setAlpha methods. On the left here, we're just calling setAlpha on each view we're animating, and on the right, we're calling setAlpha on the underlying drawables. And as we see here, the viewer on the left starts to stutter as we scroll more and more, and the perf becomes worse with all the allocation of hardware layers. Whereas on the right, the viewer stays smooth throughout. Now we also need to be mindful of what we're redrawing on screen. We should only be redrawing the views that changed and avoid any unnecessary work on views that didn't change. For a list view, this means updating only the views that we need to instead of just calling notify dataset changed, which updates the entire list view. Especially in the case of the viewer, we wouldn't call notify dataset changed during our animations because we only want to update the current video and the next video to play instead of the entire list. For example, if you're scrolling upwards, then we only want to update the center video and the bottom video, but not the top video because that one will be going off screen and we don't need to update any state on it. Now, there are also useful tools provided by Android that you can use, that you can and should use to debug performance issues in your UI that I use for the viewer as well. For example, if you're using hardware layers to optimize your animations, you can use the show hardware layers updates to make sure you're not invalidating the layer too frequently, causing performance regressions and stuttering your UI. Now, as you see in the screenshot, the view will flash green whenever the hardware layer is updated on that view, so you can tell if you're invalidating the hardware layer too many times by mistake. Now, also you can use profile GPU rendering with the on-screen as bars option to see whether every frame is rendering under 60 milliseconds. Now, this is to achieve 60 frames per second so that the UI feels natural to the human eye. And this is and the line of 16 milliseconds is indicated by the green line near the bottom of screen. As long as the bars stay below that line, your UI will feel really smooth to the user. Now, as I was building the viewer, there were small optimizations that I did that really made differences in improving the overall product quality. And no matter what kind of app you're working on, little bugs and imperfections here and there can really add up to hinder the user experience. For example, I realized that I wasn't making sure a view was visible before I started animating it, which meant that some of the initial animation values were not reflected correctly and the animation looked a bit funky. Now let's take a look at this example. Now on the left, instead of starting with exactly 0 height, the black background starts at some height above 0. So we miss the initial part of the animation. It's a little hard to see even with the slow-mo, but it becomes more clearer when the animation is reversed. Now on the right, the background starts at exactly 0 height. And now this may not seem like a big deal, but when these animations are sped up, it could be the difference between a flashing black light as you get on the left versus the intended effect of turning on an old television into the viewer, as you would get on the right. Sorry, I guess the animation screwed up. Okay. So now even little things like correctly aligning elements in your UI really goes a long way. What I've learned is that often designers give dimensions that look off on a real device, and I need to eyeball the numbers so that the UI will look appropriate. Also, there are, again, tools in the Android dev options that you can use. Show layout bounds is my favorite one. It's really helpful with alignment and figuring out padding and margin issues, as you can see in the screenshot with all the colored markings. And then the pointer location option shows you the exact coordinates of where you're touching on screen, which you can use to verify that a view is placed at the correct X and Y position, for example. That's just one use case. Now, just before we finish off, I want to show a demo of the first event we ever featured on Immersive Viewer, which was last year's Halloween. This actually has real videos we featured on Halloween, and I really enjoyed watching them, and I hope that you will too.
I'm making sure they only take one piece of candy. He stole their candy.
Cool, yeah, that's my favorite one. Now, to sum it all up, what have we learned? We learned about what the Immersive Viewer is and how the team at Instagram approached building this new surface in the app, going through different product churns and incorporating user feedback. We also learned that performant interfaces combined with animations can provide really delightful experiences for the user. And last but not least, we learned that little details can make a big difference in the overall quality of a product. Now, after all these learnings, I hope I've convinced you enough that we can really build high-quality Android UIs that feel just as good or even better than iOS ones. And hopefully you will go build some really cool UIs yourself. Thank you.